Solving systems by graphing. We have solved systems with elimination and substitution, and I have mentioned how you're always looking for where two lines intersect. Well, there are actually three possibilities. You could have one answer because it could be that your lines intersect in one spot. That would be the first. You could have infinitely many solutions. That's if the two lines were right on top of each other and they corresponded with every ordered pair. So there'd be an infinite number of ordered pairs that worked in both equations. Or they may not intersect and they have no solutions in common, in which case, yes, it's no solution. Another way to say some of these things is inconsistent and consistent. Consistent just means it has a solution. That means that exactly one solution and infinitely many solutions are consistent because they have solutions. An inconsistent system would have no solutions. That is this one here when they're parallel. They don't intersect. They have no ordered pairs in common. A couple more definitions. If you have an independent system, it says that they have different slopes. But what that essentially means is that they have a unique solution. An independent system has one solution, a unique solution. A dependent system doesn't have unique solutions. There are infinitely many of them. And notice that it says they have equal slopes and equal y-intercepts, meaning they're the same equation. So independent means they have one unique answer, and dependent means that they have an infinite number of common answers because they're the same equation. No solution is neither independent nor dependent. As you go through these questions, just be aware you're always looking for a solution they have in common, an ordered pair that works in both equations. And graphing is a crude way to do that. And I say crude because if your numbers were large, a graph isn't very practical. But this is good practice for you to go through and understand what's happening. So there were two equations that made the blue and the red line, and they intersected right here. And it looks like they're counting by twos. So this ordered pair has an x of 4. Remember, they're counting by twos. But we're only halfway down, so the y would be -1. And the solution to the system then is 4, -1. Your ordered pair should have parentheses. Here's another system where we can see the solution. Again, they counted by twos. So that looks like that is -3 for x and -2 for y. So the solution they have in common is -3 and -2. Now, as far as which one, you may be able to look, but an easy way to do that is take one of these equations. Let's take that one, in fact. -4x minus y equals 14. Take that equation and just solve for y. Move the 4x to the other side. You have to add it, so it's going to become positive. -y equals 4x plus 14. Now we divide by -1, and the equation becomes y equal -4x minus 14. All the signs change when I divide it by -1. That -14 is this line right here. It's the red line, and that was the top equation was the red line. At the bottom of the page, -4x minus y equals 14 is the same equation as y equal -4x minus 14. It's this one. That would be the red. This would be A, and the other line must be the blue. In this question, you're supposed to match the three different situations that can occur when you solve a system. Now, it's hard to tell here, but evidently those two lines must be the same, so there are infinitely many solutions. In this case, they're parallel. There are no solutions. And the last one, there would just be one solution. I noticed in the pull-down box for this top question here, that they say the system is dependent, infinite solutions. Now that's true. The system is consistent, one solution. Well, this question is consistent because consistent means it has a solution. It does have a solution, but the only one that is correct there, that could be correct, because this one has infinitely many solutions, would be that it's dependent. So this is dependent, and it has infinitely many solutions. And the next one, I noticed the pull down box is it's inconsistent. That's the new term we learned, inconsistent. And for the last one, that one is consistent, but it has one solution. In this question, the system is inconsistent because it doesn't have a solution. They share no ordered pairs, and there are no solutions.